Last week, I put out a video showing you how to measure a milliamp signal without blowing the fuse in your meter. And two comments came up that were really good and I wanted to address. First one of you had a really good eye and noticed on the analog simulator, I was actually in current source mode. Yet when I went through my description in the video, I described it as being in 2-wire mode. The other comment was I did not stress the importance of making sure that I followed this actual video because the fuse in the meter is quite costly. Now, first of all, the fuse in the 87B is costly because you want to protect your investment. Do not shortcut and get an off-brand fuse. But similarly, I did not want to blow the fuse in that meter or damage it in any way because it was on loan. And by running the analog simulator in current source mode, I was able to limit the current that would have gone through that meter if I accidentally did short it out instead of acting like I shorted it out. Here's a sketch for an upcoming video on 2-wire versus 4-wire, but we can use it to explain what I was protecting against. In our video or when you're doing your testing, right here would be our analog simulator, and it regulates the current going through the circuit. If I take my leads and put it across here in milliamp mode, this shorts out the part that is actually regulating the current. Now, there should be additional current limiting in your PLC, but I will tell you a ton of PLCs do not have any additional current limiting. Whereas here, if I'm on current source, there's actually no way for me to short this out and blow the fuse in the meter. Now, I want to use this as an opportunity to show you the 100% wrong way to test your 4 to 20 milliamp analog circuit. And a lot of you do come into my class thinking that you can do this. But many people will tell me, well, you can simply short the 24 volt and the PLC input out and see if your meter pegs. And the issue with doing that is not all PLC inputs can handle the current. Also, you got a bunch of wires here. Are you sure which two actually need shorted out? And are you sure while you grab your pigtail to actually do your testing that you can? And the answer is you can't, because you used to do this every time that you would come to my class, and I had to modify my lessons to prevent what I'm getting ready to show you here. But so I should, if we were going to actually, well, there you go. I just did it by accident. Wow. All right, we're going to have a replay on that now probably. But all right, let's talk about what happened, because this is exactly the problem that I actually wanted to show you, and I just accidentally did it. But we go to short that out, and we actually touch those two wires together. And when we do that, this compact logic has an electronic fuse on its backplane. Now, if you notice in the beginning of the video, these lights were flashing. In fact, you can see over here, we're still getting the indicators like they're flashing. But the moment we accidentally touch those together, this thing is done. It is not going to talk anymore. And this was a big issue in Tuesday in my class. It would happen every week. And what I ended up doing, which is coincidentally why I did it in the flute meter series, is I put this in current source mode. That way the entire network was coming out of this. So to fix this, I'm going to have to turn the power off. And I'm going to have to turn the power back on once it clears. And then we're going to have to wait a minute. Now, let's talk about this minute that we're having to wait, because a lot of you, when you come to my class, do not take this part seriously. I just did a video talking about downtime, small business downtime, like companies that are a little larger than Amber and I probably. Their downtime, when you actually add up all the lost opportunities and everything, is about $150 to $450 a minute. So that moment that I cut that, they've just lost 150, 450. We're finally back on. If you're a medium-sized company, that little mess up right there is $20,000 a minute. You just paid to come to my training. So now let's do it with our meter in current source mode. Because first, here's the two wires I accidentally shorted. And if I take them across the meter, then the PLC continues to run, and I get a high voltage warning. The ALP2 knows that it cannot regulate the current, so it shuts off at that point. And if I get a current 2-wire, just to see that it's still protected, if I touch the two across it that way, well, it simply regulates a signal. So totally by accident, And I think I'm gonna leave this video just like this, just like I just winged it. I hope you understand the danger of shorting out your analog signals to try to test them out because you saw what I just accidentally did. And also be really, really careful. I will not name brands, but there is one brand out there, and it is very popular that if you do that with, you will burn the analog inputs out. Now, I did just do the video on current 2-wire and current 4-wire, and I believe that is something you need to really understand to measure a milliamp signal. So click here to follow me over there.